Good morning, students. This next problem, we have to start with 51. Okay, and I'm going to jump some problems which are similar problems already we have discussed before. So 51 question says that an electron of mass, if they don't give mass, you have to remember this value 9 to the power of minus 31 kg, 9.1 sometimes, but sometimes approximately indicated as 9 amperes, is sent into an electric field of 9.1 into 10 to the power of 6 Newton per coulomb. Find its acceleration. Okay, the answer. Acceleration of the charge in electric field. Formula we can get from this force. Force acting on the charge Q in the electric field is F equal to QE. From Newton second law, F is also equal to MA. And but Q is nothing but equal to electron charge. For the relation to get the acceleration, you remember this formula please. Acceleration A equal to QE by M. This QE is electron charge minus E. Negative sign only indicates that electron has a negative charge. Acceleration is opposite to electric field. So you get this A minus comes related to this electric field. Next is substitute the value of acceleration of this electron charge is 1.6 to the power of minus 19 coulombs and electric field given as 9.1 to the power of 6. Mass is 9.2 to the power of minus 31. 9.1 cancel, 10 to the power of minus 1 take the numerator becomes plus 31. So plus 31 you will get minus 19 plus 6 is minus 13. The result will be 18. So you will get the answer acceleration as 1.6 to the power of 18 meter per second square. And negative sign already indicates, negative sign indicates the opposite electric. I didn't take the negative sign here because I took the modulus here. Modulus means positive only, but in this question they didn't give the option to negative. Sometimes if they give, you must be able to identify that. Positive charge plus negative charge is minus for the accelerations at the last is. So options given for us in this coincides is first one. This is the answer. Next question is 52. Next question is 52. Two charges 50 microcoulomb and 100 microcoulomb are separated by distance of 0.6 meters. Separated by 0.6 meters. Find the electric field at midpoint. Electric field at midpoint between them. So two charges if you take Q1 and Q2. At the midpoint means half of the distance you have to take exactly at the center point. The total distance R this will be R1 and R2. R1 will be equal to R2 equal to total distance by 2 means 0.3 meters it becomes. This R is equals to R1 equal to R2 total equal distances but midpoint is 0.3 meters. Okay, and Q1 is 50 microcoulombs. We convert into coulombs. Then microcoulomb is 10 to the power of minus 6 coulombs. Similarly, another one is 100 microcoulombs. For positive charge, electric field is directed from positive charge. Negative charge means towards negative charge. But both are given here positive charge only. Electric field is directed away from. So for Q1 is also electric field is away. Q2 is also electric field is away. So midpoint means distance is equal means the charge dominates more. More means the direction of electric field and magnetic also. So two fields are taken in the opposite directions because both are like charges, both are positive charges also. And 100 is more, therefore E2, electric field E2 because of Q2 is more than that of E1. So this E1 is less than E2, opposite directions. Without this opposite direction, net field E0 at this point, not center point O, E0 is equals to E2 minus E1, large minus small. If you take E1 minus E2 does not matter, if you get negative sign, means opposite direction, what imagine. What we imagine opposite direction. So midpoint is taken for both positive charges, E1 and E2 are in the opposite directions. Net electric field is equals to E0 equal to E2 minus E1. You can calculate separately E1, separately E2, take this subtraction, do that for theory examination. For competitive exam, don't do that. Direct formula, you better try to do it. From the just a small sketch of the diagram, if you take you will get a direct idea whether you have to take it plus or minus. Opposite direction is minus. So E2 minus E1. E1 and E2 electric field is Q by 4.7 to R square is the formula here. For potentials, in case potential formula single charges means only R comes in the denominator. For a dipole, R cube comes in the denominator. You have to be careful with that. Numerator terms will be different maybe. So here electric field E2 minus E1. 1 by 4 to Q2 by R2 square minus 1 by 4 to Q1 by R1 square. 4 by epsilon take it out and this R1 and R2 both are equal to 0.3 meters. So this also 0.3 meters square, 0.3 meters square take out. Then you will get this as 0.3. Sorry, 1 minute, I have to take calculations here. Square is there. 0.3 R2 square equal to R1 square. Taken out means becomes equal to R1 square only. That means 0.3 square becomes. So this becomes is 0.3 square, 0.3 to 0.3 into Q2 minus Q1. You get the relationship here. Q2 is 100 microcoulombs, Q1 is 50 microcoulombs. So result is this 9, 3 into 3, 9, 9 and cancels, 0.1, 0.1. So numerator you take 0.1, 0.1 is 100 you will get. So you get this as 900. 900 by 9. 9 cancels. You will get a 100 10 to the power of 9. This 100 in minus 50. 100 microcoulombs minus 50 microcoulombs. Micro take out common 10 to the power of minus 6. 100 minus 50 is 50 only. The result becomes equal to this 50 and this is 100. That means you get as 5000. 5000 means 5 into 10 to the power of 3. 10 to the power of 3 minus 6 is minus 3. So 9 minus 3 becomes equal to 6. The answer is if electric field at the point is 5 10 to the power of 6 Newton per coulomb or volt per meter. Units for this electric field, both the possibility is that Newton per coulomb also, volt per meter also. The answer is among these given values 5 into 10 to the power of 6. That is the second question. See the problem. Next one you can do work out easily. Square light charges are at the all carbon center point midpoint electric is 0. And next problem is also the triangle. Pendulum bending to the side. Candida is equals to F by mg. Simple problem we already discussed before. You will work out that. So I am stating those problems. I will do next. 56. Charges 10 microcoulombs and minus 90 microcoulombs. Charges 10 microcoulombs and minus 90 microcoulombs are separated by 24 centimeters. Find electrostatic field strength from the smaller charge is 0 distance off. Electric field is 0 from smaller charge at a distance of dash. What is the formula for null point? Null point x equal to r by under root of q2 by q1. Unlike charges means minus 1. This is null point, correct? One is a plus, another one is minus, but this is smaller, so you will find outside, not inside. Here is a null point. Here is 0, this is r. They may ask for q1, they may ask for minus q2 also. Okay, then cut off that. Okay, the charges, unlike charges. So, charges 10 microcoulomb minus 1 separate by distance 25 centimeters. This r is 24 centimeters. X you have to find out. This is nothing but equal to electric field is 0 in it equal to 0. The distance x from q1 equal to plus 10 microcoulombs. Here q1 magnitude is less than q2 magnitude. Why? Because q1 is 10 microcoulombs positive, q2 is minus 90 microcoulombs. You have to check up only by magnitude. So the distance x equal to r by under root of q2 by q1 minus 1 outside for unlike charges. So the values and q2 by q1 no what I have taken should be magnitude only. X equal to r is separation is 24 centimeters. So this is 24 centimeters, same units, okay, by root of 90 minus modulus by 10 minus 1, which is equals to root 9 you will get. Root 9 is 3, 3 minus 1 is 2. This will be 24 centimeters by 2, which is 12 centimeters from Q1 is equals to 10 microcoulombs. If you are asked from Q2 and a distance r plus x, 24 plus x, and at r plus x is equals to 24 plus 12 is 36 centimeters from larger charge. Large means actually by magnitude. From Q2 equal to minus 90 microns. So they may ask this or this. In this case, you check up. Options given. 12 centimeters. From smaller charge by magnitude is the question. They are only write it as by magnitude, not by the sign convention. By value. By magnitude, just take it as they may not ask in the examination, they don't give like that, they write it. And however, I think 36 option is there. Okay. First option is the answer. Next, 57. The proton of mass m, charge E is released from rest. U is 0. Starting from rest means U is 0. In the uniform electric field of strength E, find the time taken by them to travel the distance d in the field. A proton of mass m, charge E is released from rest. Released from rest. In uniform electric field of strength E. In uniform electric field E. Electric field density or electric field strength E. Find the time taken by it to travel distance d. Find the time taken by it to travel the distance d. S equal to ut plus half et square, because in consider t is given. T you have to find out, time you are asked. So t is required. Mass is given, charge is given. First you have to take the expression for acceleration. What is the formula for acceleration? Already we have discussed before. Acceleration is nothing but equal to acceleration of charge in electric field is E is equals to QE by M. Means it is nothing but equal to EE by M. It's the acceleration, sorry. Acceleration. Then what is also is distance is given. Distance from the equation of motion related. Starting from rest. U is 0. Starting from rest. If they ask for final velocity, no. V equal to U plus L. Distance traveled means S equal to UT plus half AT square. But distance given as a symbol D is given. So S represents the D. Equation of motion if S equal to UT plus half AT square. This S itself is D will take it. Yes. U is 0, so this part becomes equal to 0. Only this part is there. T we have to find out. So D is equals to this is 0. It is half into E acceleration. Acceleration is equal to EE by M into T square. We want T, therefore T time taken. T is equals to 2 M D by EE. This T square is there means it becomes equal to under root. 2 M D by EE is the answer. next is 58 force. This is very important one. Similar kind we will find even for the potential also. 3 types of problems are there and the similar ones. Infinite number of the charges. Of charges. Infinite number of charges, each of value or each of magnitude q. Each of magnitude or value q or on the x-axis the distances of or on the x-axis at the distances of on the x-axis the distances of 1, 2, 4, 8 meters, 2, 4, 8 and so on meters. N particles you can take from origin. Find the intensity of electric field at origin. Find the intensity of electric field means E. At origin. Find intensity of electric field at origin. So here several charges you are taking, all charge same value q, but distances are 1 meter, 2 meter, 4 meter, onward. Sometimes you have to behave here, they may give in centimeters. Centimeters here means most of the students mistake the conversion of units only, that you have to be careful. Here what you are finding is electric field at the origin you have to find out. N charges you are taking, or infinite number of charges you can take. So we are taking this x-axis and y-axis. This is x-axis. Charges are kept, this is origin here. All are positive charges only. This another kind problem they will give sometimes some plus, some minus also alternately. This is q. One more q. Like this you are taking. Distances. This r1 is 1 meter. This r2 distance from origin is 2 meters. Next distance is 4 meters and 8 meters and so on. Okay, electric field formula what we have, electric field with a single charge, other positive electric field. All positive or all negative in this case. All positive means, for example, positive charge means electric field is away. You are asking at the origin. At the origin here, you will find the electric fields are all added this side. E1 plus E2 plus E3. Charges same but distance are more. As the distance the electric field value goes on decreasing, but you have to take the addition of all these particles up to infinity. So this type of infinity is relation of total field I am taking here E0. Total E0 is equals to E1 plus E2 plus and so on you have to take. So total field. Answer at origin, total field E0 is equals to E1 plus E2 plus and so on you have to take. Relation is 1 by 4 pi epsilon naught into q by r1 square plus, and this is common, q by r2 square plus, charge is same as r3 square plus and so on up to infinity. Substitute the values no what you get. Sometimes in the options they will give with the value. In the question they will give the values, charge how much value. Or options are they will give 9 10 to the power 9 times. That you have to be careful. Sometimes only symbols give means leave this proportional constant as it is. So this E0 becomes equal to 1 by 4 pi epsilon naught into q also take out common by 1 by 1 square. 1 by 1 square. Next plus 1 by 2 square 2 meters. Plus 1 by 4 square plus and so on. This is the infinite series summation. This first one is 1, next is 1 by 4, next is 1 by 16 and so on. So this becomes equal to E0 is q by 4 pi epsilon naught into 1 plus 1 by 4 plus 1 by 16 plus and so on, whatever it is. This is nothing but equal to taken as a summation to infinity. This is summation to infinity. Summation to infinity is formula is there for it. Infinite series. Infinite series sum. Yes, infinity is equals to a by 1 minus r. You don't require to write all these steps actually for the problems for the examination, for competitive exams. For theory exams they may ask, still not asked, but they may ask. Because last time they asked the question which is supposed to be asked only for the competitive exams. So they may ask sometimes, very rarely. But you must have to work out. So for theory exams you are writing, you must write the steps. For competitive exams, no, minimize the steps. Already you know which is constant here, only distances. So directly you can jump for this formula or this formula, directly you have to go for it. Then substitution of this you will get this formula you can take. A is what is first term. R is what is a common ratio. Common ratio leaving the first term you take this second term by first is common ratio. So first term in the series, first term A is equals to 1 and common ratio R is equals to second by first means 1 by 16 by 1 by 4. 1 by 16 by 1 by 4. You get 1 by 16, 4 by 16 can be result. 4 by 16 means what? 1 by 4. This is equals to 1 by 4. So result. Therefore E naught. Result is Q by 4 pi epsilon naught. 4 pi epsilon naught into the summation to infinity. Summation to infinity is A is 1. A is 1 by 1 minus R. 1 minus 1 by 4. This will be 4 LCM to take, no, 4 minus 1, 3. 4 go to the numerator, 4 by 3 will get. Result is Q by 4 pi epsilon naught into 4 by 3. If you cancel 4 and 4, you get a 3 by epsilon naught. They are giving like such, they will give sometimes that you have to check up the options. Based on that, you have to select the answers. Q by 3 pi epsilon naught is the answer. Okay, first option given. I'm not writing options here, we can check out that. So in this case, sometimes it's the same problem. It's coming somewhere else. Problem will be given alternately unlike charges they will give. Alternately unlike charges means what? One is positive, minus, plus, minus, like that. If they give like this problem, this one, first you take plus, minus, plus, minus in this part, plus, minus, plus. So this common ratio terms changes. You take this as 1 by 16 by 1 by minus 1 by 4 you get. The result becomes equal to this becomes a minus. This minus means what we get is a plus comes. So the value will change. And options may be given with the proportional constant 9 into 10 to the power of 9 also. Answers. They may give substitution of 1 by 4 epsilon 9 into 10 to the power of 9. Like that also may be given options. So you check out that. Based on the options also you have to check mark out. That is already there. The question number 60. Question number 60. Infinite number of charges. Each of 5 nanocoulombs are placed. Here charge is nanocoulombs. Okay. Value is given for you. So each charge is given. 5 nanocoulombs are placed on the x-axis at a distance of 1, 2, 3, 4 centimeters. You get the units of the distances and so on. Consecutive charges are opposite sign dipolars. Find the electric x equal to 0. It's 59. This is also important problem. The previous problem is also important. Very, very important. Infinite charges. Charges each of 5 nanocoulombs. Question number 60. Sorry. This 60. 59 is F equal to QE. Directly get calculated. Infinite charges, each of 5 nanocoulombs are along x-axis or on x-axis at distances of 1 centimeter, 2 centimeters, next is 4 centimeters, and so on. Careful with this centimeters here. When I give 1, 2, 4, and so on centimeters, be careful with this. Find electric field and consecutive charges have opposite sign. Consecutive charges have opposite sign, means one is plus, another one is minus. Find electric field at x equals 0. Net electric field x equal to 0 means at origin. X axis, origin, here is q, here is minus q, q, minus q, and so on. This is x1 or r1 I write is 1 centimeter and r2 is 2 centimeters and so on. So net electric field at origin, net value E0 is equals to E1 plus E2. That's I'm sorry in vector form, but one is positive, another one is negative. Along the same line means it becomes equal to minus plus E3 and so on voltage. Okay, and this step you can skip. Directly you have to take E0 is equals to 1 by 4 pi epsilon naught. Q also common, you can take that also if you want. Q by R1 square minus Q by R2 square plus and so on plus and Q take out common, so I write here directly Q. So you get as E0 is equals to values are putting. This is 9 into 10 to the power of 9. Charge is 5 into 10 to the power of minus 9. 1 by, careful with the units place, centimeters. That's coming in the denominator. That to square coming. Square coming. Centimeter square. You have to be careful with that. This is 1 minus 1 by 2 square plus 1 by 4 square and so on plus. Here you have to be careful with that 1 by centimeter square. Centimeter is 1 centimeter equal to 1 centimeter is 10 to the power of minus 2 meters. So 1 centimeter square is 10 to the power of minus 4 meters square. So if it is 10 to the power of minus 4 meters square comes in the denominator. So coulomb per meter square, leave it units here. Converting into SIs. The result will get 45. Power cancels. 45 into summation to 1 minus 1 by 4 plus 1 by 16 plus and so on. So this E0 is equals to 45 into, I am doing the step here directly, summation to infinity is A by 1 minus R. A is how much is 1 is equals to 1 by 1 minus common ratio is 16, 1 by 16 by 1 by 4. This ratio is 1 by 16 or is 1 by 16 by minus 1 by 4. The result is minus 1 by 4. Step probably summation to infinity. So this becomes equal to 45 into 1 common ratio. This summation to infinity, the bracket part is 1 by 1 minus of minus 1 by 4. This becomes is 1 plus 1. This is 45 into 1 by 1 plus 1 by 4. LCM if you take now, this becomes equal to 5 by 4. This becomes equal to 5 by 4. 4 go to the numerator. This is 45 into 4 by 5. 5 nines are. The result is 36. 36 Newton per coulomb or volt per meter. Forgotten. This 10 to the power of minus 4 negative